くりレ夢ムです。
ゆっくりマリサだぜ。
Hi, Raimu Marissa. Hey guys. The Infinite Monkey Theorem, the strangest proof in mathematics.
ゆっくりしていってね。
Section 1. Hook. Here's a statement that sounds completely insane. If you sat a monkey down at a typewriter and it typed randomly, hitting keys with no pattern, no intention, no thought, and you let it type forever, it would eventually produce the complete works of Shakespeare. Word for word. Every play, every sonnet, Hamlet, King Lear, A Midsummer Night's Dream. All of it. Perfectly. Not approximately. Not close. Exactly. And not just Shakespeare. It would also produce every book ever written. Every book that will ever be written. Every email you've ever sent. Every conversation you've ever had. Every document that has ever existed or ever will exist. All of it. Randomly. From a monkey. Now here's the thing that makes this genuinely strange. This is not a joke. It's not a metaphor. It's not an exaggeration. It is a proven mathematical theorem. And the hidden truth buried inside it is one of the most disorienting things mathematics has ever revealed about the nature of infinity, probability, and what randomness actually means. Section 2. The story begins. The story of the Infinite Monkey Theorem begins not with a monkey and not with a typewriter. It begins with a thought about stars. In the late 1800s, physicists were wrestling with a disturbing question about the universe. If the universe is infinitely old and contains infinitely many stars, why is the night sky dark? Shouldn't light from infinite stars fill every point of the sky? This became known as Olber's paradox, and the attempts to solve it forced scientists to think very carefully about what infinity actually means when you apply it to physical reality. At the same time, mathematicians were developing a new framework for thinking about probability and randomness over infinite timescales. And from that framework emerged an idea so strange that it sounded more like philosophy than math. The formal version of the Infinite Monkey Theorem is usually credited to the French mathematician Émile Borel, who stated a version of it in 1913. Borel wasn't writing about monkeys because he liked animals. He was writing about the nature of probability. He needed a vivid, memorable example to illustrate a mathematical concept that his readers would find almost impossible to accept. He chose monkeys and typewriters. The image stuck. The theorem spread. It was quoted by scientists, writers, philosophers, and comedians. It appeared in Arthur Eddington's 1928 book on the nature of the physical world. It was cited by astronomers, by information theorists, by computer scientists. And every time someone explained it, the reaction was the same. That can't be right. But it is. And understanding why, really understanding it, requires pulling apart three separate ideas that human intuition treats as the same thing, but are actually completely different. Probability, infinity, and time. Section 3. The evidence. Let's build the case carefully. Because the Infinite Monkey Theorem is not hard to state, but its implications are genuinely strange. And the strangeness goes deeper than most explanations admit. First piece of evidence. The probability of any specific sequence is never zero. Start here. A monkey hits a key at random. There are, say, 50 keys on a typewriter. The chance of hitting any specific key is 1 in 50. The chance of hitting two specific keys in a row, say, T then H, is 1 in 50 times 1 in 50. 1 in 2,500. The chance of typing the word "the" is 1 in 125,000. The chance of typing the opening line of Hamlet, "Who's there?" is 1 in 50 raised to the power of 12 or so, an astronomically small number. The chance of typing all of Hamlet, roughly 130,000 characters, is 1 in 50 raised to the power of 130,000. That number is so small it has no name. It's smaller than the number of atoms in the observable universe raised to the power of itself, many times over. It is, for all practical purposes, impossible. But here's the critical point. It is not zero. 1 in 50 to the power of 130,000 is a tiny number. But it is a real, positive number, not zero. And that distinction, between almost impossible and actually impossible, is where the entire theorem lives. Second piece of evidence. What happens when you try infinitely many times? This is where the investigation gets genuinely strange. There's a mathematical result called the Borel-Cantelli lemma. It's not easy to state precisely, but here's what it means in plain terms. If an event has a fixed non-zero probability, even an incredibly tiny one, and you repeat the experiment infinitely many times independently, then the probability of that event never occurring approaches zero. In other words, if the probability is above zero and you try infinitely many times, it will happen. Not probably, not likely, with probability exactly 1. The monkey typing Hamlet has a probability that is not zero. Given infinite time, infinite attempts, the probability of it not happening collapses to zero. The probability of it happening is 1. Certainty. At first, this seems like a math trick, a manipulation of symbols. Then investigators looked at what it actually implies and discovered something unexpected. Third piece of evidence. The monkey will type Hamlet infinitely many times. Here's where it gets even stranger. The theorem doesn't just say the monkey will eventually type Hamlet. It says the monkey will type Hamlet infinitely many times. Not twice, not a million times, infinitely many times. Because once you've established that any finite sequence will appear, that its probability of eventually occurring is 1, that applies at every point in the infinite sequence. After the monkey types Hamlet the first time, it still has infinite time left. And with infinite time left, it will type Hamlet again, and again, and again, forever. The monkey will also type Hamlet with every possible variation. Hamlet, but with one letter changed. Hamlet, but with every third word replaced by a random word. Hamlet followed immediately by Hamlet. Hamlet spelled backwards. Every possible mutation of Hamlet will appear infinitely many times in the infinite typewriter output. But that's where things became strange in a different way. Fourth piece of evidence. The monkey also types everything false. Here's the evidence that investigators don't always mention. The one that makes the theorem unsettling rather than just remarkable. The monkey doesn't just type true things. It doesn't just type existing books and real history. It types everything. Every false account of history. Every incorrect scientific theory. Every forged document. Every persuasive lie. Every piece of convincing misinformation. The monkey will type a version of Hamlet where Hamlet is a villain. A version of the Bible where Jesus says things he never said. A history book where World War II went differently. A scientific paper that looks legitimate but contains completely fabricated data. A medical text full of dangerous false claims that reads like the real thing. All of these will appear, interspersed with the real Shakespeare, the real history, the real science. And here is the hidden truth that the theorem buries inside its remarkable promise. In infinite random output, you cannot tell the real documents from the false ones just by reading them. A real copy of Hamlet and a fake copy that's nearly identical both appear somewhere in the infinite output. They both look exactly like what they are. The infinity that gives you everything also gives you every convincing imitation of everything. The theorem doesn't just produce Shakespeare. It produces infinite forgeries of Shakespeare, right alongside the real thing, with no label. Section 4. Theories. The theorem is true. The math is established. But what it means, what it actually tells us about randomness, infinity, and the universe, is deeply contested. Let's go through the serious interpretations. Theory 1. The theorem proves that complexity can emerge from pure randomness. This is the most popular interpretation and the one most often cited in discussions of evolution, cosmology, and the origins of life. The argument: if pure randomness, given enough time, can produce the entire works of Shakespeare, then pure randomness, given enough time, can produce anything, including complex biological structures, including life, including intelligence. The theorem is cited as mathematical support for the idea that no designer, no guiding force, no intelligent agent is required to produce complex, ordered structures. Given enough time and enough randomness, everything appears. The strength: it's mathematically correct. The theorem is proven. Given infinite time, random processes produce all possible finite outputs. The weakness: given enough time, is doing an enormous amount of work in that argument. The time required for a random process to produce Hamlet is not just long. It's longer than the age of the observable universe by a factor that makes the comparison meaningless. In any finite universe with a finite lifespan, like the one we actually live in, the theorem provides essentially zero practical comfort about the power of randomness to produce complexity. The theorem is true in the mathematical world of actual infinity. Whether it applies to a universe that is merely very old, not infinitely old, is a completely separate question. Theory 2. The theorem is a warning about infinity, not a promise. Some mathematicians and philosophers use the Infinite Monkey Theorem not as evidence that randomness is powerful, but as a demonstration of how counterintuitive mathematical infinity is. The argument: the theorem sounds wonderful. Monkeys produce Shakespeare. Randomness produces everything. But follow the logic carefully, and it reveals something uncomfortable. In truly infinite random output, every true thing appears. But so does every false thing. Every correct proof appears, alongside infinitely many documents that look like correct proofs but contain hidden errors. Every valid scientific theory appears, alongside infinitely many theories that are wrong but written in convincing scientific language. Infinity is not a truth filter. It's not on your side. It produces everything indiscriminately. The theorem is a warning. Don't mistake infinite output for meaningful output. Don't mistake the fact that truth appears somewhere in infinite randomness for the idea that randomness is a reliable path to truth. The strength: it captures something real about the relationship between infinity and meaning. The weakness: it's more philosophical caution than direct insight. The theorem itself doesn't make any claims about meaning. That's an interpretation layered on top of the math. Theory 3. The theorem connects to the nature of information itself. This is the most technically sophisticated interpretation, and it connects the Infinite Monkey Theorem to Claude Shannon's information theory and Kolmogorov complexity. The argument: the theorem tells us that all possible finite sequences of characters exist in infinite random output. But information theory tells us something equally striking: that most of those sequences carry no meaningful information at all. Kolmogorov complexity measures the information content of a string by asking, what is the shortest description of this string? A string of random characters has high complexity. You can't compress it, you can't describe it more briefly than just writing it out. But a structured document like Hamlet has lower complexity. You can describe it by referencing the source, or by describing the patterns that generate it. What the Infinite Monkey Theorem produces is mostly high-complexity random noise. The meaningful documents, Hamlet, scientific papers, historical records, are islands of structure in an ocean of chaos. Infinitely many islands, yes, but surrounded by infinitely more ocean. The theorem is true, but most of what the monkey types is not meaningful. Finding the signal in infinite random noise, even knowing it's there, is its own unsolved problem. The strength: it connects the theorem to practical questions in computer science and information theory. The weakness: it requires accepting a particular technical definition of meaningful that not everyone agrees with. Theory 4. The real experiment has already been run, and it failed. In 2003, researchers at Plymouth University in England actually gave 6 Sulawesi-crested macaques, a type of monkey, a computer keyboard for 1 month. They called it the Monkey Shakespeare Simulator. The results: the monkeys produced 5 pages of text, mostly the letter S, some A's, a few other letters. The dominant behavior was hitting the keyboard with a rock and urinating on it. Not a word of Shakespeare. This theory says, the theorem is mathematically interesting but physically irrelevant. Real random processes, including actual monkeys, don't behave like the idealized random process in the theorem. They have patterns, biases, and physical limitations. The theorem's monkey is a mathematical abstraction. Real randomness is never perfectly random. The strength: it grounds the discussion in physical reality and correctly notes that idealized mathematical models don't always translate to real systems. The weakness: it misses the point of the theorem, which was never about actual monkeys. The monkey is a thought experiment. Criticizing it for not working with real monkeys is like criticizing Newton's frictionless inclined plane for not existing in the real world. Section 5. The most likely answer. Here's what the full investigation reveals. The Infinite Monkey Theorem is true. Completely, rigorously, provably true. That's not in dispute. The math is solid and has been for over a century. But what it means, what it tells us about the real world, requires careful unpacking. The theorem is true in a mathematical universe where infinity is actual, where infinite time is available, where perfectly random processes can run forever without physical constraints. In that mathematical universe, the theorem's promise is complete. Every finite sequence appears. Hamlet appears. Everything appears. But we do not live in that mathematical universe. We live in a physical universe with a finite age, approximately 13.8 billion years. And the time required for a random typing process to produce Hamlet even once is so far beyond the age of the universe that the comparison is essentially meaningless. The hidden truth is this: the Infinite Monkey Theorem is a statement about mathematics, not about physical reality. It's a demonstration of how infinity works, not a practical claim about what randomness can produce. What the theorem actually reveals, and this is its genuine value, is the structure of probability itself. It shows that impossible and probability zero are not the same thing in mathematics. An event can have probability zero and still occur. An event can have non-zero probability and be so unlikely that it effectively never happens in any finite context. This distinction between mathematical possibility and practical possibility is one of the most important and most frequently confused ideas in probability theory. The Infinite Monkey Theorem makes it visible in the most dramatic way possible. It also reveals something about infinity that human intuition cannot naturally grasp. Infinity is not just a very large number. It is qualitatively different from any finite quantity. Things that are true of infinity: all finite sequences appear, every event with non-zero probability occurs, are not true of any finite number, no matter how large. A monkey typing for 1 trillion years will not produce Hamlet. A monkey typing for 1 trillion years will not produce Hamlet. The numbers required are so incomprehensibly large that they might as well be infinite, except they're not. And the difference between almost infinity and actually infinity is the difference between the theorem being false and the theorem being true. That gap between the finite and the infinite is where the real mystery lives. Section 6. Conclusion. Here's what I keep thinking about after investigating this theorem from every angle. Emile Borel chose monkeys and typewriters in 1913 because he needed an image that would feel absurd. He wanted his readers to react with instinctive disbelief, so he could then show them that the math forced the absurd conclusion anyway. It worked. 110 years later, people still have that reaction. And that reaction, the instinctive sense that this can't be right, is pointing at something real. Not a flaw in the theorem, a genuine feature of infinity that human cognition was never built to handle. We evolved to think about numbers up to maybe a few thousand. Numbers in the millions become abstractions. Billions are beyond intuitive grasp. Trillions are functionally indistinguishable from a lot. Infinity is not a lot. Infinity is a completely different kind of thing. And the Infinite Monkey Theorem is one of the cleanest demonstrations of that difference that mathematics has ever produced. Here's the experiment that stayed with me longest. In 2011, a programmer named Jesse Anderson built a computer simulation of the Infinite Monkey Theorem. Not real monkeys, virtual ones. Millions of virtual monkeys generating random text simultaneously, running on Amazon's cloud computing platform. His virtual monkeys found the first sentence of A Midsummer Night's Dream in about 2 weeks. Not the full play, one sentence. 2 weeks of millions of virtual monkeys running simultaneously. Anderson calculated that finding the full play would require resources and time so far beyond anything currently available that it was effectively impossible in practice. Even with every computer on Earth working together for the entire remaining lifetime of the universe. The theorem is true. The monkey will type Shakespeare. And also, in any practical sense, in any finite universe with finite resources, it won't. Both of those things are true at the same time. And that's the detail I can't let go of. Somewhere in the infinite random output of a truly infinite process, your name appears. Written in context. In a sentence that says something true about you. Every secret you've ever kept. Every thought you've never said out loud. All of it. Not because anyone put it there. Because in infinity, everything is there. The monkey isn't writing Shakespeare. It's writing everything. And the mystery isn't whether that's true. The mystery is what it means that a universe of pure random noise contains, somewhere, buried infinitely deep, every true thing that has ever been said, and every false thing that sounds exactly like it.